Okay, to get ready for our next lesson, we are going to review adding and subtracting fractions. So what we're going to do is we're going to do a couple practice problems, and you're going to do some practice, and then we'll be ready for our lesson tomorrow. Remember, when you are adding or subtracting fractions, and this is adding or subtracting like fractions, we're going to go over if they don't have the same denominator, but to add or subtract fractions with the same denominator, you're going to write the sum or difference of the numerators over the denominator. So all you have to do are add or subtract the numerators and then keep the denominator. Okay, so if we look at the first example here, of course, and then actually I'm going to add, after you add or subtract and keep, you should always simplify. Alright, so I'm going to start zooming in a little bit, makes it a little bit easier to write when I'm zoomed in. So here, if we add or subtract, in this case we're going to be adding, okay, the numerators, 3 plus 2, we're going to do on top. We're going to keep the denominators. The denominator is going to be 8. 3 plus 2 is 5. 5/8, and 5/8 cannot be simplified, so that's our answer. Okay? Now for this one, we notice that the first fraction is 3/5, the second fraction is 4/5, so when you add or subtract the numerators, you're going to get 3 plus 4, and then for keeping the denominator, you're going to get 5. So that's going to become 7/5, which we can then turn into 1 and 2/5. And that's our answer there. Okay. Now subtracting is the same thing. Here we have common denominators, so we have 6/12 minus 4/12. So you're going to do 6 minus 4, and then keep the denominator, so it's going to be 12. 6 minus 4 is 2 over 12, and 2 over 12 equals 1/6. Now just because the numbers are bigger here doesn't mean that anything's changed. We're going to do 30 minus 22 over 50. 30 minus 2 is 8. So the answer is 8/50, which would simplify to 4/25. And that's our answer. Okay. Now when it comes to mixed numbers, you've probably learned a different way than what I'm going to have you do. And the reason is because when you are in 6th grade, it's easy to tell students to turn your mixed numbers into improper fractions and then add them that way. The problem is the numbers get very big very fast, and if this was 33 and 3/5 and this was 75 and 4/5, all of a sudden this would become a virtual impossible problem, when it's not if you just know how to add or subtract mixed numbers. So when you're adding or subtracting mixed numbers, first you're going to add or subtract the fractions. Then you're going to add or subtract the whole numbers. And then you're going to put it together. Now, there is going to be part of this where we're going to carry and borrow when we're adding and then finally when we're subtracting. And that's okay. It's not hard to carry or to borrow when it comes to fractions, okay? So I don't want you to think like, oh, well, we can't do that. So I'm going to show you right now. So I picked these problems for a reason. So first we're going to do 3/5 plus 4/5, which equals 7/5. Well, 7/5 equals 1 and 2/5. Then those are the fractions. Now we're going to add the whole numbers. 3 plus 5 equals 8. And then we put it all together, and 8 plus 1 and 2/5 equals 9 and 2/5. This is a lot easier than changing our mixed numbers into improper fractions. If I look here, first I'm going to do 8/15 plus 2/15, and we don't have to borrow, or we don't have to carry here at all, because we get 10/15. So we're fine, but we should reduce. What does 10/5 reduce to? It reduces to 2/3. And then we do our whole numbers. 2 plus 6 equals 8. We put it together, and we get 8 and 2/3 as an answer. Okay? Again, a lot easier than doing 2 times 15 plus 8, 6 times 15 plus 2, adding these giant numbers together, and then taking that and making it into 8 and 2/3. It's a lot easier this way, okay? So I don't want you to have to stress out too much. It's not that hard. Now here, the same thing. This is where students really stress out, is when they have to borrow. So you have to do here, it's 9 1/3 minus 2 2/3, so it's 1/3 minus 2/3. But you cannot do 1/3 minus 2/3. And I know that we can get a negative number, but we're not going to do it that way, okay? What we're going to do is we're going to do just like we would if we were adding, or if we were subtracting 91 minus 26, right? We can't do 1 minus 6, so we don't put -5. We borrow from the 9 to make it an 8, right? We're going to do the same thing here. We're going to borrow. So when we're borrowing, we'll borrow from the 9, we'll make this an 8, but we're not actually borrowing 10/3. We're borrowing one whole number, right? The 9 became an 8. We borrowed 1 from the 9. So if we're looking at fractions, when we borrow 1, we're borrowing a whole denominator. So if the denominator is out of thirds, then what you're going to do is you're going to add 3/3 to the fraction. So now this is going to become 4/3. Because we borrowed 1, which is 3/3, so that's what turned the 9 into the 8, plus we already had the 1/3 that was there. That's how we got 4/3. So now this becomes 4/3 minus 2/3, which equals 2/3, and 8 minus 2, which equals 6. Put it together, and you get 6 and 2/3. We try it here. We're definitely going to have to borrow here, because we can see that obviously we're going to do 1/16 minus 9/16, and we cannot do that, so we borrow from the 5. We're going to borrow 1 whole from the 5, so it goes from 5 to 4. And when we're borrowing 1 from the 5, what we're really doing is we're going to give 16/16 to the fraction, because 16/16 is 1. So the shortcut is whenever you borrow, you're really going to add the numerator and denominator together. All right, so now I've got 16/16 plus the 1/16 that I already have. That makes 17/16. So I change this to 17/16 minus 9/16, which equals 8/16, which equals what? That's right, half. And now we do 4 minus 2, which equals 2. Put it all together, and we get 2 1/2. Now, if you're asking or going to ask me, can I turn this into an improper fraction? The answer is yes. You'll get the right number, but the answer is also no, because you're never going to have enough time to do that work. You'll run out of time, because you'll be expected to do it at a much faster pace than you can do if you turn those into improper fractions. Now, getting to the other part about fractions that you have to remember is that they have to have a common denominator. We notice that these fractions don't have a common denominator, but 2/7 equals 4/14, which equals 6/21, which equals 8/28, which equals 10/35. You see these are all equivalent fractions, right? And 1/4 equals 2/8, which equals 3/12, which equals 4/16, which equals 5/20, or 6/24, or 7/28. See how we're just making equivalent fractions. But the reason why I was showing you that is because you can see if we need a common denominator when we're adding or subtracting fractions, well, I had it right there, 28, right? So we're not going to go through all that work. What we're going to do is we're going to look at 7 and 4 and say, what do both of these numbers multiply up to? Or that's what's called the least common multiple, the lowest number that they multiply up to. And in this case, it happens to be 28. It happens to be when you multiply 7 and 4. It's not always the case that when you multiply the two together, it will be the lowest number, but when you multiply the two numbers together, it will always be a common multiple or a common denominator. So in order to turn the 7 into a 28, I multiplied it by 4, so I have to do the same to the top. 2 times 4 is 8. In order to turn the 4 into a 28, I had to multiply it by 7. I do the same to the top, and I get 7. There we go. See the 8/28 and the 7/28? And then we add them together, and we get 15/28. Now, you do have to always simplify when you get done. In this case, there is no simplifying. Here, we ask ourselves, what would the common denominator be? The common denominator would also be when we multiply these two together in this case, so it would be 22. This would be times 11, so times 11 to the top would be 11 over 22. 11 times 2 makes 22, so 8 times 2 is 16. Now I get 27 over 22, which can't be simplified, but it can be turned into a mixed number of 1 and 5 over 22. The same for subtraction, where here it would be 21, and here it would be 24, and then we're going to subtract the numerators. For mixed numbers, it's the same as before. The only difference is we're doing 1/4 plus 5/8. So before we start, we have to get a common denominator. 2/8 plus 5/8. You notice how I didn't have to change that second one? That's okay. That's good. It's even better for us. It's less work. So that's 7/8. 3 plus 3 is 6. Put it together, and it's 6 and 7/8. What would the common denominator of these two numbers be? It would be 10. Very good. So this would become 9/10, or stay 9/10. This would be 6/10, and that would make 15/10, which equals 1 1/2. And then I do 9 plus 2, which equals 11. Put it all together, and this answer is 12 1/2. Do you see how fast it is when we don't have to turn our numbers into improper fractions? Leave that in 6th grade. Same thing with subtracting. I'm going to do this one because it's a little bit more difficult. So because we are going to borrow, which borrowing isn't difficult, but when we do 3/9 minus 2/5, we look for the common denominator. It happens to be 45, which is kind of ugly, but it is what it is. So we do 5, this is 15, and then this is times 9, and so this is 18, and we can't do 15 minus 18, so we borrow from the 16, it becomes a 15, we add the top and the bottom together, okay, or we adding another 45/45 to 15/45, and we get 60, okay. Now we have 60 minus 18, which is 42 over 45, which can be reduced. I'm not going to do it right now because I'm running out of time. And we have 15 minus 10, which is 5. 14. Okay, so this is 14/15. So we put together, and it's 5 and 14/15. Okay, so those are your rules for adding, subtracting fractions and mixed numbers. We're going to be working on this more tomorrow, except there'll be positive and negative in class, okay? So make sure that you're familiar with all of these.